1 day on, 1 day off back in the day there. Right, that was your freshman year. Was that? Oh, great, even better. Freshman year was complete shutdown, right? So maybe you got to this, maybe you didn't. Maybe I should have went a little slower last period. All right, I totally forgot about that. So here's the deal here, guys. I got two ships. I got ship A and I got ship B. And they both have an equation associated with them. Ship A, y equals 2x. Ship B, y equals x plus 5. And I want to know what the coordinates of the lifeboat are. The lifeboat, if you read, are when those two ships cross each other. Okay, when they cross each other. So basically, when are those two equations going to be equal to each other? All right, so I got two of them here. Y equals x plus 5. And I also have y equals 2x. What I'm doing with you today is reviewing how do I solve two equations at a time. All right, that's what I'm doing today. You probably use two methods. Anybody want to throw out the best way to approach this one, solving for x or y in either one of those equations? Jake?
You could put 2x in for y on the other equation.
Yeah, you guys called that substitution back in your freshman year. I take 2x or the other one and substitute it in for y. And now you should have, when you rewrite it, you should have an equation with just x in it now. Yep, that's what we're doing today. Two equations, two variables. And how do I solve them?
Subtract x.
Subtract x on both sides. Good call. So at least we know the x value is 5. And I'm going to get you out of this habit real quick. You're not done. Anytime we solve these two equations, they have two variables. So I need the value of both variables. You got x. How'd you guys back in the day get the other variable?
You just put the x into one of the equations.
Does it matter which one?
No.
Nope. So I take my x value of 5. I go back to either of the two originals and plug it in. And then I'll have my y value. So y equals, I'll take the second one, 2 times 5. So your y value should be 10. So I need an x and a y value. That's what we're doing today. And you'll practice on Monday when we get back. Anything here? Go ahead, Nick.
Can't you put it in your y equals and look at the graph to?
You could do it that way, but the problem you can do it. Yes, you can. The issue you're going to have with that is the problems we have coming up. You're not going to be able to use your calculator, and you'll see why, and I'll get back to that. But yes, you can in this case. You can. Everyone's good? Okay. Next type of problem, which is not two equations, two variables, but we need to make sure we're good with it. I guess they don't teach break even anymore in economics, huh? They don't talk about businesses break even. Okay, that's fine. We got some canoes. Anybody? Do I have any canoers in here? Anybody? You've canoed before? Stayed in the boat?
Yeah.
Anybody else canoe?
Yeah.
Nick, canoe, yeah?
Have you done white water rafting?
Everybody
We're
knows.
tough. No.
That's fine.
My mom fell out on the
We're tough.
nuts and bolts, or like isn't that like a term? It's like really dangerous.
I'm not an expert.
Fell.
Anybody else canoe?
Yeah.
All right, no big deal.
All
All right, so here's the deal. We sell canoes in here. All right, we sell canoes. Fixed cost. Let me talk about that first. There's a fixed cost of $18,000. What that means is, I don't care how many you produce or sell, you still have to pay me $18,000 for making the canoes. That's called a fixed cost. No matter how many you sell, you still owe $18,000. No matter how many you sell. It takes $20 to make a canoe, and you know what? We're going to sell them for $80 a canoe. All right, $80. It takes 20, but we're going to sell them for 80 to make a little money. How many canoes do I need to sell to break even? What that means is break even. I don't owe any money, but on the flip side, I don't make any money. All right, we're just plain even, break even. So that's what this means here. So break even, your cost of making the canoes will be equal to, and I'm going to use a word hopefully you're familiar with, revenue, which is the money you bring in from selling the canoes. All right, so that's your break-even point. Is the cost of making a canoe will be equal to the money you bring in, the revenue of making one. And the problem tells us we're going to let X equal the number of canoes. So we're going to use X here. All right, so let's go on the left side. Talk to me about how much it takes to make a canoe.
$20.
Okay, $20 a canoe, right? So 20X, but there's more though. Yeah, it costs 20, but what are we on the hook for no matter how many? The 18,000 also has to be included in the cost. Plus 18,000. Your fixed cost must be in there. So that's how much it's going to cost. You set it equal to how much money do we bring in for the canoes? $80 for every, and what do I put with the 80? For every canoe. There you go. There's my break even. Cost, how much it takes to make them, plus the fixed cost, equal to how much we're taking in for every canoe. And then this is just something you guys solve now. There's no two equations here. All right, break even problems, there's only one you should be able to set up. So move the 20 over, right? Move the 20X over. Divide by 60. So to break even, I'm going to need to sell 300 canoes. Now again, I want to put this in context here for you. I sell 299 canoes. I owe money. I didn't make any money. I owe it. I sell 301 canoes. Now I made money. Okay, but when I'm at 300, nothing on either side. I'm good. All right, so that's what the break even means. Questions, comments, anything on breaking even before we get back to two equations, two variables? All right, we go from canoes to selling, toothbrushes and soap. Good transition. Why you would buy this many toothbrushes, I don't know, but here we go. Just so everyone knows, sometimes we can make up our own variables, but they're telling us here X is going to be your toothbrushes and Y is going to be how much soap costs. So you go in, you buy 2 toothbrushes and a bar of soap, it costs you $11. Ooh. Somebody else goes in, for whatever reason, they're going to get 6 toothbrushes and 5 bars of soap. Dirty people. $38. All right, let's solve for X and Y. How much it costs to make get a toothbrush and how much for soap. So let's do customer number 1 first. 2 toothbrushes. How can we represent 2 toothbrushes? 2X. Yep, I'm saving numbers here, not today. Plus 1 bar of soap. Just 1Y is equal to $11. Everyone all right with that? Customer number 1. Second customer goes in. Now I got 6 toothbrushes and 5 bars of soap equal to 38. And Nick, getting back to your point right now, this is why, could you solve for Y and plug them in your calculator? You could. I don't, might get a little nasty, but you could. So that's why I'm not suggesting the calculator yet. All right. So the method we used in problem number 1, where I just plug in for Y, not looking pretty here. So you guys had a second method your freshman year called elimination, where you eliminated one of the variables. I can't eliminate anything right away, but to eliminate a variable, if you remember, you multiply an equation by a number so that one of those variables will eliminate. And there's multiple things we could do here. Anybody got a suggestion? And we'll go with it as a class. You sure?
I'm sure.
All right.
The 2x plus y one,
Yep.
you can multiply that by -5.
Okay. Or anybody else have another one? You could have multiplied it by Sydney?
3.
Just 3?
3.
There you go. Okay, so I could have multiplied it by -3. Yep, good. Either one. Are you going to be offended if I take his response? Yeah, just, he gets a little drama if I don't, One thing I will harp on here, as you distribute the -5 here, please make sure it gets distributed all the way across the equal sign as well. All right, common mistake I see. There we go. So the y's do get eliminated here. Y's are eliminated. So it looks like 6 minus 10. Combine your like terms. -4x equals negative, what do I got there? 17. Is everyone all right? Stop me if you don't know where it's coming from, because we increase in difficulty every day this unit. Divide by -4, divide by -4. And remember, we're dealing with money here, so just don't. We're dealing with money here. What are we left with here? Is this the 425? Yep, $4.25 for a toothbrush. And like we did in problem number 1, take that x, go back to one of your 2 originals, plug it in, solve for y. Doesn't matter which one you plug it into. That's pretty cheap.
Now it's cheap, but I feel like it used to be like.
And if you want to go hardcore and get one of those electric ones.
I have an electric.
I'm just old, so just saying. Just give me a toothbrush. We're good. These problems are outdated. Who buys a 1 bar of soap anymore? All right, $2.50 for a bar of soap. Hey, we okay? Coming back to you a little bit from your freshman year. Are you ready to buy some chairs? Rocking chair and Adirondacks with a footstool, updated with a footstool. You can buy it for $320. But if you just want the regular brand, $265. Wow, look how much you earned, about almost $14,000 for 48 chairs sold. How many rocking chairs were sold? All right, here is where you can start getting creative now. I didn't say x equals this, y equals x. You can make up your own variables. Me personally, I like my variable to be associated with what we're talking about in the problem. Like we're talking about rocking chairs. So I go R right away. I go R for rocking chairs. Now, hey, do what you want. You want to go XY? Go ahead, stay XY. You want to go K for rocking chairs? Go ahead. I don't know why you would do that, but hey, go ahead. Whatever letters you'd like. And then we're also talking about an Adirondack chair, so I'm going A for Adirondack chair. Just let me know what your variables are, all right? So you make up your own variables. All right, now we got to come up with the equations. I'm going to try to make this easy on you. The money stays with money in the same equation. The money always stays together in the same equation. So we have what? $265 for a rocking chair. All right, so I'm going to put $265 times. Well, you put X, I put R. So that's the way I'm rolling. Yep. Plus Adirondack chair, $320 for me, A. Money stays with money. $265, $320. That all equaled the total money, $13,930. Money stays with money in the same equation. I need a second one though. I gotta somehow incorporate that there was 48 total chairs sold. I don't attach the money here.
265.
Oh no, you're attaching money, Jared. You're attaching money to it. We already did the money. That's taken care of, so I don't use the 265 again.
Oh.
But I do know there's 48 total
48
chairs. What?
48 R.
That's 48 times the number of rocking chairs. There's 48 total
Just 48
chairs.
In general?
48 total chairs. So if I got, give me a second. If I have rocking chairs over here, I got Adirondacks over here. There's a total of 48 of them. Go ahead, Amanda.
Would you make another variable like T for total?
Don't need another one. Don't need another one. I got Adirondacks over here, and I have rocking over here. Total, there's 48 of them. Total, there's 48. Nora, going to help us out?
It would be 48 plus equals R plus A.
R, rocking chairs, right? The number of rocking chairs, plus A, the number of Adirondacks, equal 48. Makes sense, everyone. Okay, no money attached to it. No money. We already got that done. All right. What do you want to multiply by? It's your call. Works. Whoa, 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 whoa. Hey, kid, before we make a decision and you put something down on your paper, let's work smarter, not harder. What do I mean by that? Read the problem at the end. This is a one where I'm not looking for both rocking and Adirondack. What am I only looking for? Yeah, I'm only looking for the rocking chairs. So I might want to get rid of A here. All right, if you get rid of R, that's fine. You're going to have to plug it back in at the end, but let's try to get there the most direct way. So what can I multiply this equation by, the second one we made, to figure out the number of rocking chairs? Negative 320. Got it. Yes. Negative 320. Hey, and is it okay if you ended up solving for A instead? Yeah, that's fine. You just got to go plug it back in to get me R. All right, distribute all the way across. Negative 320R minus 320A equals, I got to look at my, negative 15,360, I think.
Yeah.
Good deal. All right, Adirondacks cancel each other out. Combine your R's now and your right side of the equal sign. I'm getting negative 55R on one side. And on the other side, I'm getting negative 1,430. Yeah, I'm good.
Yep.
So I'm going to have how many rockers? 26 rocking chairs. And again, I can't stress this enough. If you ended up solving for A and eliminating R, plug it back in. All right, it's not going to hurt you. Any questions before we go condos to end it?
The 1390. 13930.
We're good? Sydney, all right?
Yeah.
Okay. I'll make sure we're good here because we got a lot of zeros. Just be prepared here. There's going to be a lot of zeros in your calculator and on your paper here. A lot of zeros. All right, a little condo action here. 1 bedroom and 2 bedrooms, 50 of them total. You guys see how much they charge for each type. 1 bedroom's $120, 2 bedroom $150. Whew, that's a lot of money we got from sales. So how many of each did we sell? All right, first thing, you guys want to be creative? Variables you want me to throw up there? I don't want to stay X and Y. That's too original. What do you got? Your own one? Is there, Amanda? Don't give me O.
I can't.
You tell me why.
Oh, never mind.
Why? Tell me why.
Because isn't it a number?
Well, then it's going to look like what?
A 0.
Yeah. And look at all these zeros I got already. And there's definitely, I'm going to make a mistake here somewhere. So go ahead. What's the other? Give me another one.
Well, T and C. I don't know.
Where'd C come from?
Condos.
Oh, okay, you got me. You got me. You got me there. All right, so C equals 1 bedroom. And T equals 2 bedroom. Yep. Again, you don't like the way we're rolling, make up your own. I just wasn't a big fan of O because it probably will look like a 0, and you're going to see how many zeros we have here in a second. Easy, boss. You good?
Bro, I can't use pen anymore. I mess up too many times.
How about you bring your own stuff? Yeah, that'd be great.
Probably.
Yeah. All right, everyone ready? Money stays with money, right? Money stays with money. So it costs 120,000, a lot of zeros, to make for a 1-bedroom. So for me, 120,000 C plus 150,000 C T. Jeez, be careful of your zeros. There we go. T, and that totaled 7 million, huh? Money stays with the money in the same equation. All right, don't attach money anymore. How can I introduce the 50 now? Go back to last problem. C plus T equals
Equals 50.
why 100?
Wouldn't it be 51 and then 52? Or are they just saying 50 in total?
That's what they're saying.
Oh, okay.
Yeah, that's what they're saying. So take all your bedrooms and add them up, and there's 50 total. Yep. I see we're going the other way. All right, it doesn't really matter here. There's no working smarter here. You got to solve for both, it says. Find the number of type of each unit. So you either multiply by negative 120,000 or you multiply by negative 150,000. It's up to you. Guys, please take your time too. All right, a lot of frustration last class just because we forgot a 0 in the calculator. We forgot to write one down on the paper. Keep track of it. Take your time. I'm not going to write anything on the board to confuse people. You figure out what you want to multiply by. Take your time. And yes, you should be getting whole numbers of 1 bedroom and 2 bedrooms. Can't have partial ones.
What, bro? Did I mess up again?
I have 8 points, and it's not right. I know it's not right.
Oh,
Look at
yeah,
your
I
zeros.
was
Look at your
figuring
zeros.
Oh. Yes, man.
Is that 7 million or is that 7 million?
Not
Is that 7,050,000?
No, it's 70 million. No, it's 7 million.
Okay.
Could
Yeah,
you
I
have
think
a
so.
comma here and another comma
I
here?
got it.
This is
That's what I
7
I'm on.
million. 50,000.
You know what? I'm cool.
That's right. Got to subtract out the 120,000. That makes sense.
Oh my god.
Now I've got,
Um,
I better eat this one.
no, then we'll mess it. Just because mine's dead.
I'll make the test really like show work
35.
for this, or
I would at least need to see your two equations in a little bit.
if you could just kind of like put it in the calculator.
What do you mean, guess and check?
No, you can just put it in the Y thing. Do it.
So you're going the Nick way.
Uh,
But don't you have to blow up your window and stuff, right?
you just do that.
Okay. All right, man, that's fine. As long as I would at least need the two original equations. So.
Nice. Oh, I forgot. Oh, that was the year.
You haven't even done it, that's fine. Okay, wait. I was ready.
Sure, my
15, one bedroom?
Yep.
And there's got to be 50. Now, I'm hoping you guys aren't stressing yourself out here. You get 15, don't plug it back into this huge money one with all the zero. There's got to be 50 of them total. All right. I don't know if anybody's stretching yourself out. I'll just plug in 15 into the big one here, and then just do it here. You do the easier one. We got 35. Yep. 35, two bedroom. All right. Monday, usual deal. All right. I'm not changing the sequence here. You come back and we practice these. Quiz will be Thursday. Coming quick. It'll only be on 2 topics.